Hello everyone, welcome to Study UTech. This is solution of electrical machines MCQ questions. If you haven't watched the previous videos, please watch them. Okay, so these questions are on induction motor MCQ questions. Okay, so let's start. First question, what is being asked? The slip, you have to calculate the slip and the parameters are given. So slip equal to ns minus nr by ns into 100. Okay, we have solved this type of question previously, probably the same questions, but the thing is that to calculate the ns, this is equal to 120 f by p. So 120 frequency is 50 hertz by p equal to 4. But look, in the questions it is not given the 50 hertz. Okay, so I am assuming the line frequency to be 50 hertz for our standard. So this is equal to 1500 rpm, right? So this is equal to 1500 rpm minus 1440 by 1500 into 100. Okay, so the answer will be 60 by 1500 into 100, that is equal to 4%. So the answer will be this one. What is the next question? The power drawn by three-phase induction motor, it is first in star, then it is connected in delta. Look, this is a very interesting question. Okay, so we have to let's prove it. Okay, this will be the answer. Let's say this is the star connected rotor, these are the rotor resistances, and this is the another phase, this is the star connection, and in delta connection, let's say this is the delta. Okay, this is the delta, and phases are, let's say this is phase A, phase B, this is the phase C. Okay, here this is a phase A, phase B, and phase C. So A, B, C, A, B, C. I'm assuming one thing, that is the resistances are 1 ohm for the sake of calculation, balanced. Okay, this may not be 1 ohm, the proof will be same also, but for the sake of calculation I am taking 1 ohm. Okay, so let's say we have applied 10 volt here. So voltage between lines are, I am calculating for one phase, that will be similar for the three phases also. Okay, so 10 volt is being applied here. So this is the V line, and what will be the voltage from this point to this neutral point? This voltage will be 10 by root 3. Okay, 10 by root 3 volt, and this is called the phase voltage, V phase. And so relationship equal to VL equal to root 3 V phase. Okay, so and IL, look, the current flowing in the phase equal to current flowing in the line, so IL equal to I phase. So remember, these are important for induction motor, or the star connection. Okay, so what will be the power here for this phase? Power will be P equal to V phase into I phase, and for three phases 3 into this one. Okay, so 3 into 10 by root 3 into current. Look, 1 ohm resistance, so voltage and currents are same, so 10 by root 3. Okay, so this will be 100 watt. Okay, so remember this one. The same way we will calculate for delta. Okay, for delta, see here, the voltage between this, same voltage is being applied here. Let's say this is equal to 10 volt, and this is a VL here. Okay, now look, the voltage, that is the line voltage here, the voltage is for this delta connection, same voltage appearing across this line, so that is equal to V phase, and VL equal to V phase equal to 10 volt, same volts, but current will not be same, because current flowing in this line and that line, and the current flowing here, it will not be same, because this current is coming, this current is going, so this current will be the line current, and this current will be the phase current, and the relationship is IL equal to root 3 I phase. Okay, anyway, so this is the relationship, you can remember. This is true for delta, this is true for the star. Many times this relationship will be required, remember, forever. Okay, so the power here, this is a P for star, right? The P for delta equal to V phase per phase, V phase into I phase is the power multiplied by 3, because 3 phase, so this will be 3 into 10 into 10. Why I am taking this 10? Because 1 ohm resistance I have taken, that's why I have taken 1 ohm resistance for the sake of calculation, but you can take R, it will be a bigger calculation. Okay, so this will be 300. Okay, 300 watt. Okay, so what you got? P delta 3 times P star. Okay, so this will be 3 times of P star. Okay, I hope you understood. Let us go to the next question. The frequency of the induced EMF in the rotor circuit is, this will be the answer, maximum at standstill. Because remember one thing, whenever the induction motor is there, this is the stator, this is the rotor, three-phase supply is given to it. The line frequency is that we are giving is a F hertz. Now, some current will be flowing, the voltage will be induced in the rotor side. Okay, so in the rotor side, Fr, the frequency will be slip time the frequency, supply frequency. Okay, this can be proved. Anyway, remember right now. Okay. So what we got, the rotor frequency is slip time the supply frequency, so SF. Okay, so what is being asked here, they are asking when this rotor frequency will be maximum. Look, S equal, okay, so S equal to ns minus nr by ns. So what you can see here, the when S will be maximum, look, the value of S is varied from 1 to 0. When it is equal to 1, when the nr equal to 0. Okay, so ns by ns equal to 1. That is possible only at standstill condition. Okay, so rotor is not rotating, it will just about to rotate. Okay, so S equal to 1, that is called the standstill condition. But once it is starting, rotation is being started, then ns minus something will be deducted from here, so it will deviate from the 1 value, 0.8, 0.7, something like that. Okay, so gradually it come down. So the maximum will be when S equal to 1, that is possible at the standstill condition. Okay, I hope you understood. Next, let us go to the next question. The speed in which the stator magnetic field rotates is called, well, this is a synchronous speed. I hope you know. Let's recap. If you give the balanced three-phase supply to the stator, the fluxes will also be balanced. So we can say this is a phi A, phi B, and phi C. Phi A, phi B, and this is a phi C. Okay. Now, taking at the different points, 0 degree, 30 degree, 60 degree, I think you know if you have not studied these things. So go through the part. Okay, so the magnetic field, taking the resultant of these three phasors, you will get the resultant phasor will be somewhat this one, that is rotating. Okay, so this is called the rotation of the magnetic field, or the rotating magnetic field, and speed at which it rotates is called the synchronous speed, ns. And the important formula regarding this, 120 f by p. P is a number of pole, f is a supply frequency. Okay, so let us go to the next question. The resistance R0 is the exciting branch of the equivalent circuit of the three-phase induction motor represents. Look, let us draw. Well, let me take the phasor, the equivalent circuit. Okay, this is a induction motor equivalent circuit. Okay, so they are asking what is this R0. R0 basically represents the core loss. Okay, core loss is a hysteresis and eddy current loss. That is a core loss. And this shunt branch, look, this series branch, this R and this X and this X represents the leakage reactance, are the winding resistance, they are connected in series. Okay, and this shunt branch represents the core loss component R0. The current is responsible for the core loss is IW square into R0, as because this is a real power loss, that's why this is represented as a X, sorry, it represented as R. And this is a shunt branch X0 represents the magnetizing component which is required for setting up the flux. Okay, so this R0 will be the stator core loss. Why not rotor core loss? Because the rotor frequency is S into F, and whenever the induction motor is rotating, the rotor frequency falls down drastically because slip is decreasing. Okay, is coming to 0.3, 0.4, 0.1 or something like that. So it will be lesser than that also. Thus, the rotor frequency is very low, and this core loss, hysteresis loss, and eddy current loss, they depend on the frequency. Okay, so the frequency has, because one hysteresis loss is probably proportional to F and eddy current loss is proportional to F square, so it will be the lesser than the it is very lesser, you can neglect it. So basically the core loss in the supply side, in the stator, the core loss will be the higher than the rotor, that's why it is significantly higher. That is why the stator core loss, the answer will be the stator core loss. What is the next question? The induction motor is supplied with the voltage having frequency F, and S is the slip of the motor, then the frequency of the. We have discussed this concept previously, that is FR equal to just sometimes before, that is equal to S into F, right? Slip times of the frequency of the supply. So this will be the answer. Look, if you can remember few things, you can answer many questions like FR, rotor frequency, is equal to S into F, the synchronous speed equal to 120 F by P, then slip equation is NS minus NR by NS in percentage multiplied by 100, all these things. Okay, so remember all these things at the make the build the concept. The MCQ questions will not be difficult, because based on one concept many MCQ questions can be formed. Okay, so I hope this is the last question. Well, this is the end of this induction motor MCQ questions on question discussions. If you have any queries, you can put it in the comment box. If you have liked the video, please share it among your friends, and subscribe the channel, press the bell icon to get notification for further video upload. Thank you.